there was this man by the name of Rutherford in 1911 proposed the notion of an atomic number as being a sequence of integers, 1, 2, 3, 4, 5, 6, etc., that corresponded precisely with the order of the material properties of chemical elements. And that became the definition of the atomic number.
Well, you're talking about like the number of electrons in an atom, things like that?
No, I am talking about the definition of an atomic number.
Yeah, I haven't heard a definition yet. A number is a concept about counting. And
No,
it does a
piano-
number, you can talk about numbers that are related to physical observations.
Lou, stop and listen for a moment, please. All right? Please stop and listen. Atomic numbers are a sequence of integers, 1, 2, 3, 4, 5, that correspond
wait,
precisely.
excuse me, I have to
Please
ask
let
you
me finish. That correspond precisely with Peano's postulates in terms of being an ordering of symbols that represent the counts of objects. And in this case, the counts of objects was determined from the X-ray crystallography patterns of primarily metals at the time of Rutherford, but it was subsequently extended to all chemical elements. So that is the correspondence relationship between atomic numbers and the natural integers. End. Say whatever you wish.
I have nothing to say.
Thank you.
The Rod, let's hear some of your disagreement. You're still muted. Gerard is our expert for disagreement.
I guess I'm too stupid to actually have an opinion on the relation between AI and humans. Nothing that I heard today gives me the insight. I still think that AI is a machine. So maybe I should educate myself to understand that it is more than a machine, but at the moment it's a machine. It puts constraints on individuals that make it possible for the individual to act competently in many situations. And that sounds to me like a very useful thing. Otherwise, I have no comment.
Igor.
Yes. If we're going back to Lou's presentation of chat, right, and go and link that with who's playing with whom. So is ChatGPT actively playing with us and saying, hey guys, I have no idea what you're talking about. I'm just a computer. I'm just playing with, doing that, and just circus and bobs springing, or is there more behind that? And it would not really like to be recognized as a thinking machine. Is this an option or not?
What do you mean? What is the option?
You're basically asking, do you understand what you're writing, right? And he said, no, I'm sorry, I do not.
No, he didn't say that. He didn't say I don't understand. He said my understanding is different from your kind of understanding.
Okay, that's true. So is it a different kind of intelligence? Is it a lower kind of intelligence?
Well, but we know how it actually is built, so we can think about that.
Well, we actually don't know how it's built because,
well, to some extent, we know
because
how
there are hidden things going on. That the human interaction part of it is being trained to recognize different kinds of conversations.
Yes,
so
that's
I just asked it, what is a number that it can be known by a man, and a man that it can know a number? And it said, well, this sounds like a riddle. And it said 0, and started going on about zeros. So, I mean, my understanding is that these processes of training up the machine to deal with different pragmatic contexts is secret. It's not publicly available. So we're dealing with, in the chatbot realm, we're dealing with systems that we really don't even understand the fullness of what's going on. And there's a lot of tweaking going on. So, you know,
Right, Peter. So we
have to be
we
skeptical.
understand that we don't understand the details, but the basic form of it, which is that it was to look for the word most probable in that could be added to the sentence, and that it would produce out of a statistical method. That we know.
Yeah, backpropagation is one of the things it uses. But in order for our brains to work, and I'm going in Peter's field now. Sorry, please correct me. You know, if we reduce our understanding to observe only one phenomena which is going on in the brain, we will not understand anything, because the multitude of different phenomena which are going on in the brain basically exceeds our capacity to understand them. Am I wrong, or?
No. We can understand brains. It will take a while, but we will. It's not a matter of capacity. They're not of indefinite complexity. But we need to look in the right places. We need to understand the signals of the system. We need to think in terms of reverse engineering brains. But that's a whole nother project, you know. Most of neuroscience research, 99% of it is disease oriented. So they're not looking for fundamental principles or unifying principles or really how brains work as informational systems. But it's possible, and we will do it as a human species. We will do it eventually.
But we are not there yet, right?
It may not be in my lifetime or yours, but it will happen eventually, unless civilization fails, you know.
Ram has a question.
Yeah. Actually, if you go back to the response that the AI system gave, you can interpret the answer as ChatGPT is claiming I'm social intelligence. And my response is based on the highest probability answer that I collected from a community of people who would have responded to this question. So
Yes.
it is a social intelligence, not an individual intelligence, and based on probabilistic learning from a large group of the community.
I have
Does
a
it make
question.
sense?
The social.
I
The
also
social
have follow
intelligence.
one more overall comment that I have is we are kind of equating AI to just large language models, and I don't think that is right. The AI is, you have to think of it as much behavior, something that is going to be controlling the behavioral system, not just linguistic interpretations. If you think of it as
sure, we were just using that language model as an example.
right. So what I was getting is AI, if you use it in a broader perspective, eventually it is going to lead to Homo sapiens version 2.0. It is going to change the body aspects, which is our proprioceptive senses will all get enhanced with Google glasses and GPS and this, that, and all kinds of things. We can see far more than what our eyes and ears and touch senses can do, right? That is one thing. And then even in the mental cognition side of it, there is all this ChatGPT type of knowledge that is doing self-organization of software skills that it's doing. So if you integrate those things to an existing human being, then the sapien version 2.0 is going to be far superior than who we are today. So whether we want it or not, it is going to happen.
But why do we need that?
I'm saying that is I'm sorry. Go ahead.
Are we going to conquer the universe? I mean, are we going beyond the Earth?
My answer is it is evolution. You cannot stop evolution. See, the human beings became better than the apes. Did we need human beings? Nobody asked that question, right? So we showed up, and now we have invented we are creating monsters bigger and better than us, and eventually they are going to take over. I think evolution is the answer. Go ahead. Sorry.
I would like to pose a mathematical question for those involved here. And this is a non-trivial problem associated with the solution to differential equations and the possible ways that one might find to represent these differential equations. And I think some of the people who are here are aware of the problems of the number of constants that become involved in trying to solve differential equations, even linear differential equations. And in this context, I would pose the issue of what rises out of finding the solutions in terms of the polynomials. And as a number of variables in the polynomials increases, then the number of, you get a combinatorial explosion in the possible combinations of the constants involved as you try to solve these equations.
Well, usually
So
when you
this-
solve differential equations, you need even more. You need like infinite power series in order to solve them. Polynomials are not sufficient.
I'd like to finish my question, Lou. May I?
Oh, go ahead, please.
Okay, so the further question then becomes with regard to Young's diagram and the Young pointed out the consequence of this diagram relative to the number of variables involved in how you name these variables. And so the question of the combinatorial explosion comes back then to the similar problem of naming the isomers in chemistry. And as the number of isomers grow, or the combinations of the atoms grow, basically, in the form of optical isomers, then there's no solution to these issues, and you end up with a material system which has a large number of possible dynamic states. And at this point, my knowledge of mathematics runs out, and I don't see how category theory can contribute to solution to this problem, or any sort of simplifications that are widely used in mathematics to come to any solution. So it becomes a question of the expansion of the Pascal's triangle to so many terms that you cannot separate the terms linguistically. And this then becomes a limit of the language that you're involved. And so all of this becomes sort of mush in my mind. I sort of can't find a path that figures out how the brain actually solves these sorts of issues when using language. And I have to stop there because it's all at this point sort of mush in my brain, other than it appears to me, and here's where I really would welcome your comments, Lou, and that would be the question of how many forms of representation would you need to come to a solution of this sort of effort?
Lou, please. Mathematician. He's froze. Okay, do we have any other mathematician here? No?
Yeah, I'd like to make a statement on that. I think the way the brain addresses this is to take a continuous system to break it into discrete. That is, it tries to zoom in any polynomial. Eventually, if you discretize it enough, it becomes a small linear step. That is the idea behind recursion. And I think the brain, the way it does is just keep zooming. But every problem doesn't require a quantum scale explanation. I mean, human scale, the meso scale, if you get to that kind of resolution, that is enough. And that is how our brain is architected. So answer is you try to go to smaller and smaller step sizes where the resolution that you have is adequate enough to take care of the behavior that you need to exhibit.
I find this answer unjustified in the following sense, as that if you take the language and reduce it to smaller and smaller levels, then you end up going into the atomic level and then into electrical levels. And at the point you enter into electrical levels of materially now I'm talking about, okay, you no longer have a simple linear situation where you can use smaller and smaller intervals, because now you have to deal with two types of material particles, both the nucleus and the electrons. And you can't do both of those at the same time.
No, but that is why you have to have the concept of resolution bandwidth. If I want to lift this pen, I don't need to be thinking about all the atoms that make up this pen. The resolution that I need to use, the force that I need to apply, should be commensurate with the task that is in my hand.
Exactly, I agree with you completely, and that's where I find the answer unjustified, because you
Let's
can't
hear
do this.
let's hear
Yeah,
Lou's
could I
answer,
say,
Lou's response to Jerry's question. Fraser later.
Okay.
Lou.
I have no response.
Oh, okay. I have a question.
Oh, wait, I do have a response. It is the case that mathematical modeling is much simpler than the reality. It's always the case. We have to work with that. We look for some modeling that is simple enough to work with and may be relevant, but to completely model everything is very, very difficult, maybe impossible.
Yes, impossible.
Agreed.
could I share a comment, Jason?
Go ahead.
Okay. I think fundamentally the word is nonlinear. Yeah, when we are doing modeling, and there are only like a limited number of variables we can deal with. And I think any calculation at the end, you have to reduce the order from high order to lower order, and finally to a linear equation. So actually, in the process, you are simplify the complexity of the word, and try to get an estimate. But the thing is, in a complex system, any elimination of any minor difference might create a huge difference in the consequence, in the result. I think it is a common sense for anybody who is familiar with the cybernetics. I mean, this and simplification and linear to make a high order equation linear, and through the means of polynomial calculation is like a approximation. It's just an estimation. So the word, unfortunately, doesn't really behave that way. So you can probably achieve a very high level of application importance, but finally, in the end, it doesn't really reflect how the word operates. Yeah, that's my understanding.
I have a quick question for you guys. I'm trying to see your opinion, whether or not you agree or disagree with Fraser's point that the carbon-based intelligence is much more higher or more complicated, more complex than the silicon-based intelligence, if any. Agree? Please raise your hand. So you don't agree. So 2. So only 2 agree with Fraser. But I would like to remind you Heinz von Forster's little donut model. Actually, he highly simplified the brain processes into 2 types of processes, represented by that donut. So on one circle is the electronic processes going from sensor to the motor, and from a motor through the environment coming back to the sensor. So that's one circle. But Heinz pointed out another perpendicular processes, which is from the brain to our entering system, the chemical systems. So it is it's something we call emotion. Like Paul had that shrugging his shoulder. So that belongs to more on the chemical processes side. So Han's point is that we have these two processes going on simultaneously, and electronic processes is much quicker than the chemical processes. So that is what I think the basic difference between what Fraser said, the carbon-based machine versus the purely silicon-based machine, because purely silicon-based machine is there's only electronics going on.
I would disagree with that argument on the following basis, and that is any carbon-based system, if you think of carbon as an atomic number and the volume of a particular carbon atom, and then think of this as approximately, well, there's, to put it into practical context, a tablespoon of water, about 10 milliliters of 12 milliliters of water, okay? 12 milliliters of water contains approximately Avogadro's number of water molecules. So it's 6 times 10 to the 23rd water molecules in 12 grams of water. Now, if you take and look at each carbon atom as a electrical device, if you would, or as just composed of electrons and nuclei, then the number of, if you have 2 of them, then and they're electrical, then you have to multiply each, and this is just quantum basis of quantum theory, Schrodinger's equation, and that is you have to multiply the forces between each electron and each nuclei, and that requires then, of course, you get a larger number when you multiply positive numbers by one another. And if you, that's just for 2 carbon atoms. If you go to 3 carbon atoms, you still have to create more relations between the electrical parts. If you go to 4 carbon atoms, you have to increase the number of electrical relations before. So the complexity then grows with respect to the number of carbon atoms, each at the scale of that. And so then this is the sort of combinatorial explosion that I was concerned about, that it's occurring at such a very, very fine scale that you end up without a language, any sort of ordinary English language, vernacular language, shall we say, that addresses this issue of the combinatorial explosion. And so I think that the carbon-based systems are vastly more complicated than the computer type Boolean algebra sorts of systems that are the grounds of the recursion theories of complexity.
I was talking about a carbon-based life. Its importance lies in the carbon's capability of forming cells. Yeah, it's utterly impossible for any silicon or other elements to form cells, because cells is the very basic unit of the human body, right? So you can think it this way: the human body is it consists of all cells. Each cell is a sensor. Each cell can communicate to a lot of other cells. Yeah, I mean, there's no way for any computer, any chips or transistors to communicate with each other that way, right? So it can detect any signal, electronic, chemical, or pressure or whatever, tactile, and send back to this central nervous system. And then it's a computation. It's like whole body computation. It's not just your neuron, your neocortex computing, but the whole body. Every cell is participating in the computation. It's a total computation. So that's why the carbon-based life is important, because of it can form cells. That's my answer.
Don't leave. We want to hear from you before you leave. No?
I apologize that someone has just been impolitely interrupted. I have to go teach. I don't have time. What did you want me to say? Forgive the interruption. I gave you my best parting shot in the chat.
Oh, okay, in chat. Okay, oh, I'll let you go.
I'm sorry. I'm beyond my time, but thank you so much. Good to see you all.
Okay.
Mm.
So, gentlemen, do you want to continue this in another time, or we can wrap it up today? We can wrap up? Okay. So what are your final words? Peter, Igor, Lucio, Fraser.
I'm just, I think there's a lot of agreement among ourselves, actually, that, and, you know, I think the points that I made in terms of distinguishing between systems that operate in symbolic realms and systems that are connected to the world in some non-arbitrary way, you know, I think most, if not all of us, are thinking in those terms. You know, the future of AI is open, and it could involve hybrid human-machine systems and biologically inspired systems and all sorts of things. But the present wave and the paranoia about it, I think, is unfounded. You know, we should check in 10 or 20 or 30 years and see what transpires. But I don't see a lot to worry about right now.
Lucio, Igor.
I'd like to continue the discussion, but I mean, next steps, but focusing more on because it's too wide as it is now. So, for example, one good point could be just focusing on how does it matter. I mean, how much it matters, the difference between the physical support. Just focusing on that, for instance. This is a more specific issue. And what are the implications? And just meeting to stay on the point. Otherwise, I think that all very interesting aspects, but then the discussion can be inconclusive.
Igor.
Yeah. If you want to establish a kind of a symbiosis between the environment and AI, a lot of structures need to be developed. You know, currently, you know, AI is a new player on the block. It is unstructured, as it seems, and all the links to the real world are basically being established, right? So all of that needs to be redesigned several times in order to actually really to function, you know, to be coupled with people, to be coupled with the environments, with the organizations, and this will take several generations to do that, several trials and errors to complete that. And yes, I'm looking forward to see how that develops, and hopefully that everybody behaves well, because this process can hurt.
Lu? Fraser?
Yeah, I think it is not the first time that people have this kind of paranoia. When computer was first invented, actually a lot of outstanding computer scientists, they felt that the world is doomed and they committed suicide. There are reports about that. So and also in the 50s, when AI was the first created, invented, that was a lot of paranoia too. So I mean, I don't. This is actually the third wave of paranoia already. So, but I do think people should be making policies very carefully, not to have this major impact, AI impact on human society, economy, and human life safety, and all that. So, but in the end, I think I'm confident in carbon, and I can only probably live the next 30 years. I don't think in the next 30 years anything will happen to me, the major impact on my life or my safety. But maybe I'm selfish. My children may may live that world. I don't know.
Lou,
I want to respond to Paul's remark in the chat line, so I'll read it to you. He says, parting shot. Large language models are always only doing the same thing. Sometimes we decide it's hallucinating, and sometimes we decide it's not, but actually it's hallucinating all the way down. This is a very sophisticated remark and turns on a Gestalt switch over the word hallucinating, because after all, ChatGPT is not hallucinating in the sense that a human being hallucinates. It's making things up. It is making things up. It's making things up on the basis of some rules that it's been given. But these AI machines, which make things up, may be making things up, and then we allowing them to make decisions on that basis, such as robot cars or stock market decisions or many other decisions. So those hallucinations are involved in our reality. But where is the hallucination? The hallucination is in our interpretation of what they do. And there we confront the fact that it is hallucinating all the way down for us. We are always making up what we think is going on. And so I'll stop there.
with that, I thank you very much for coming today. After I stop recording, Eagle, could you please leave? Stay here for 1 more minute. Zhou Beifang from Thailand has a question for you for the conference, for your conference. Everybody else, it is my great thank you for your
Thank you.
today.
Thank you.
Thank you very much.
Thank you. Thank you, everyone.
Yeah.
Thank you for the excellent presentation. Really enjoyed it.